Alright, so for tonight's homework, Module 1, Lesson 3, I'm going to work through setting up several of these problems. I'm not necessarily going to answer them, but I will help you in setting them up so that you kind of know where to go. And if you only need like one or two, then skip over in the video to get to those questions, okay? So, starting off with number 1, it says density, like the science density, is a unit rate measured in units of mass per unit of volume. The mass of a garnet is 5 7/10 grams. The volume is 1 5/10 cubic centimeters. What is the density of the garnet? And so we have to look at the order because order matters. And it told us that we're looking for density, and it tells us that density is measured in mass per volume. So we want, when we set up our ratio over here, when we've got density is mass per volume, okay? Or we can write it as a fraction of mass per volume. And so if we have a mass, so here we've got a garnet that has a mass of 5.7 or 5 7/10 and a volume of 1 5/10, then we can just plug these numbers in to our formula here, our format, and then just plug them in our calculator. We should be able to get our answer. Alright, moving on to number 2. Jen and Camley, I guess that's how you say it, are walking to school. After 20 minutes, Jen has walked 4/5 of a mile. After 25 minutes, Camille has walked 5/6 of a mile. Find the speed in miles per hour. Who is walking faster? So in order to figure out who's going faster, we need to find their speeds for each one of them. So we've got Jen, and then we've got Camley, Camilla maybe? Maybe it's Camilla. I don't know. Camille. K. Okay? Cammy. We're going to call her Cammy. Alright, so it took Jen 20 minutes to walk 4/5 of a mile. We want to know how fast, or we want to know if she goes 60 minutes, how far can she go in 1 mile? Okay, and remember when we're solving for ratios, we can make a ratio box like this, and we can just cross multiply 60 times 4/5 times 20. Notice that I didn't put a 1 here for hour because we're talking about minutes, and they need to have the same units. So we're talking about miles to miles here. We need to be talking about minutes to minutes, and there are 60 minutes in 1 hour because that's what we're looking for, is miles per 1 hour. So there's 60 minutes in that 1 mile. That's why we use the 60 here. So we should be able to put this in our calculator, and that's going to tell us how far Jen was able to go in 1 mile. And then we're going to do the same thing for this lady over here. She went for 25 minutes. She was able to go 5/6 of a mile. Well, same thing. If she goes 60 minutes or 1 hour, how far does she travel? And we can set it up like our ratio boxes from last year. Same process, cross multiply 60 times 5/6, and then we're going to end up, oops, this should have been divided by, sorry, I hope y'all caught that, divided by the 25, and that's going to tell us how far here. So to know who went faster, the faster person is going to be able to go the further distance in the same amount of time. So whoever ends up going further is going to be the faster time. Alright, moving on to number 3. Marla and Franco are mixing sports drinks for a track meet. Maria, my bad. Maria uses 2/3 cups of powdered mix for every 2 gallons of water. That's important, for every 2 gallons of water. That's Maria. Franco uses 1 1/4 cups of powdered mix for every 5 gallons of water. Whose sports drink is stronger? Show your work as your explanation for your answer. So it's kind of going back to the same thing here. What we essentially did was we found the unit rate here, and that's essentially what you're doing here, is finding the unit rate. So you could set it up as, remember how we said in a unit rate that the second number is always 1? So if we're talking about powdered mix, 2 gallons of water, then what we want is we want the number here, the amount here, for 1 gallon. Okay, so we've been doing that, remember, just by setting it up as a fraction and dividing. So if we have 2/3 cups of mix for every 2 gallons, we want to know how much for 1 gallon. And so when we cross multiply and divide, or we just simply put this into the calculator as a fraction and simplify, we would get, so also if you're doing a fraction on top of a fraction, you got to hit the fraction button, and then you got to hit the fraction button again so that you have a fraction within the numerator. So you have 2/3 over 2, and you get 1/3. So when there is 1 gallon of water, there is 1/3 of powdered mix. Okay, so then we're going to do the same thing for, so this was Maria's. So for Franco, notice all the scratch work I'm doing as well. You should have just as much scratch work. We're going to do the same thing for Franco. Franco has 1 1/4 for every 5. So we want to know how much powder for 1 gallon. So we could, like I said, we can do the cross multiplication and then divide it by 5, or we can just strictly put it in our calculator. And since this is a mixed number to put in a fraction, remember you're going to hit the fraction button, and we want a mixed number and not just a fraction again. So you see that green right there as a mixed number. Oops, let me delete that. Okay, anytime you want something green, you're going to hit the green button, then you're going to hit that button. So you've got 1 1/4 over 5 gallons, and we get 1/4. So then you're stuck with, well, which one is a greater concentration of powder? So which one is the greater fraction? I'm going to let you figure that one out because we should know that by now. Okay, so moving on, Serena estimated that she can paint 60 square feet of wall space for every half hour. Write an equation of the relationship with time and hours as the independent variable. Can Serena paint 400 square feet of wall space in 3.5 hours? Why or why not? Show the work to support your answer. So this equation here is what we talked about last week, where we had y equals k x, where k was the constant, and then these are your two variables. So the independent variable is going to be your x value, and so they want that value to be, write an equation, time in hours as the independent variable. So your x here is going to be your time, your amount of time, where your y is going to be the amount of space that you'll be able to cover, the amount of feet you'd be able to paint, or the space you'd be able to cover with the paint, because that makes sense, right? The amount of space you're going to be able to cover is going to be dependent on the amount of time you take painting. So how are we going to do this? So this takes us back to last week when we're trying to remember how to find K. And remember, if you go back to your 1.2 notes, you should find that the constant is found with y over x. So if x represented the time, the y represented the wall space. The y represented the wall space. So if we go back to the information we have 60 square feet as our y. So if I'm trying to find k, our y is 60 square feet for every half hour. Okay, so half of an hour. We can plug this into our calculator. 60 over 1/2, and we get 120. So our k equals 120. So we're going to be able to plug that 120 into this formula, into this equation right here, and that's part 1 of our answer. Part 2 is plugging this information here and trying to see, will it equal? So can Serena paint 400 square feet of wall space in 3.5 hours? So if we take that formula that we created, y equals 120x, and we substitute x with that 3.5 hours, so 120 times 3.5, are we going to get 400 or more square feet? Yes or no? Okay. Number 5. Sherry paid $6.50 for the bunch of grapes with a weight of 2.5 pounds. What is the price per pound? Remember, per is talking about unit rate, and unit rate is what we were doing. It was back when we were trying to find the constants and all of those things. Alright, so we want to know how much for 1 pound. So to do that, we just plug it into the calculator. We just put the 650 over the 2.5, and it's going to give us our answer. And so we're going to do that same process. If you look down for numbers 6 through 9 where we're trying to find the unit rate, you're going to do the same process for all of those right there. Number 10, select all the rates equivalent to the rate 3/4 per cup per pound. You know, that's just 3/4 over 1. So what you need to do is you need to simplify all of these using this format and decide which ones are equivalent to 3/4. Alright, number 11, Lucia uses 3 ounces of pasta to make 3/4 servings of pasta. How many ounces of pasta are per serving? How many ounces of pasta should Louisa use to make 5 servings? Once again, we're trying to solve some things. So if we're trying to solve, we're going to either set it up as a fraction or set it up as a ratio box. My go-to is usually the ratio box in these types of situations because I know what the two things I'm comparing. I'm comparing the ounces to servings, right? Comparing ounces to servings. So when she has 3 ounces, that gives me 3/4 servings. Well, how many ounces per serving, remember, is 1 serving, and so we will cross multiply and divide, get our answer. Then we could do the same thing here when it says how many ounces of pasta should she use to make 5 servings. Well, instead of the 1 serving, we'd place the 1 with a 5 and then cross multiply and divide, and we would get our answer. I'm not going to go over the spiral review tonight, only because this video is already about 15 minutes long, and you should be able to do these spiral review questions. Everything above that was our new stuff, so you should be able to work through these, and if you have any questions tomorrow, after you punch your answers in, we'll go over them. Okay? I hope you have a great night.